We haven't had a Nonsense Wars repair thing in a while, so today we're going to repair and demo the 32467 speed computer, which LEGO sold with a few other bits as set 5602. The part itself consists of a rotation sensor wired to a controller display, and it can measure rotation speed, rotation distance, and time active. Unfortunately, the early 2000s vintage means that the cable is made of garbage and will need to be replaced. Even more unfortunately, taking the computer apart is semi-destructive to the casing, though it does not require any special tools. On the other hand, replacing the wire is more straightforward than replacing the 5306B wire, though you will need a soldering iron. We briefly checked that the unit powered up before starting the disassembly. Let's look at the screen side first. The black portion slides off to reveal a removable CR2032 button battery, but the visible internals don't give any hint about how to open the top part. Annoyingly, LEGO simply glued this part together, and we pried it apart with a plastic spudger. Afterward, the buttons and the PCB simply fall out. You can see the yellow glued sections on the gray casing. Let's look at the sensor side now. This side is both more and less bad. You only need to undo snaps as with the 5306B ends, but you also need to remove some material as with the M motor clips. It's especially critical to take material off of the corner snap, as that part of the casing has very little give. Even then, we had to make a jig out of a long pin and some bricks in order to help push the yellow interior section out of the gray exterior section. With the sensor side open, you can see how it works. The metal drum has a plastic ring with some bumps on it. The bumps lift the metal prongs off of the drum as it rotates, and this breaks the sensing circuit. The computer simply counts the frequency of the brakes in this non-directional mechanism to get the rotational speed. To better demonstrate this, we touch a multimeter to the two sensor prongs. It will beep when the circuit is closed. You can see that it beeps 3 times for one revolution of the drum, one beep for each bump on the plastic ring. As with the 5306B repair, we used 22 gauge braided wire, though you could probably use something slightly thinner. We cut the replacement cables a fair bit longer than the factory cable to give us some room to mess up and to simply have a longer cable. This should not affect performance given how the sensor works. Now we need to remove the old wire from each end. As we did not have any desoldering braid, we simply heated the existing solder while tugging on the ends. On the sensor side, the old wire pulled out enough solder such that we had clear holes on the prongs. As such, we could insert our replacement wire before soldering it in place. On the PCB side, the old wire did not pull out enough solder, so we reversed the removal process. We heated the solder on the PCB and pushed the wire through while it was hot. We double-checked that no stray solder joined the wires on the PCB side, since the holes are very close together. Prior to soldering, we looped the wires on the sensor side around the stress relief pattern such that everything pressed together easily upon reassembly. We replicated the stress relief crimp on the PCB side with a tiny rectangle of brass sheet, as we could not remove the old crimp from the old wire. We temporarily taped the shell back together in case anything went wrong, but it powered right back up, and now we can look at the functions in detail. The computer has 3 modes: RPM, R, and time. In RPM mode, you spin the sensor a bit and the display will record the maximum RPM that it sees. You can use the function button to reset it. In R mode, you spin the sensor a bit and the display will count the number of non-directional revolutions. Again, you can use the function button to reset it. In time mode, the display will count time as long as the sensor spins. Like before, you can use the function button to reset that. To be fair, the accuracy isn't going to be amazing in any of these modes, since the maximum resolution of the sensor is 120 degrees. But it's not terrible. To prove the point, we will use the computer to measure the no-load speed of an M motor at 9 volts. Going all the way in one direction on the regulator, we get 440 RPM, and going all the way in the other direction, we get 420 RPM. Philo's Lego website, a very reputable source for Technic motor specs, lists the no-load speed as 405 RPM, suggesting that the speed computer is accurate to a few percent and confirming that our fix appears to have worked. On that note, this is the end of the video, so have a nice day.
Peace.
Is there any sort of click or anything? How easy does it come back apart? Right now with no tape?
So now we need
that's
tape.
fine.
We need to tape it shut or glue it shut.
No, we'll
basically.
tape it shut. We're fucking gonna tape
So
it
we're
shut.
gonna
I
tape.
hate glue.